Someone is praying for you. Someone is praying for you. So when it seems you're all alone and your heart will break in two.
Welcome to our lessons on ordinary differential equation. In our previous lesson, we look at the case whereby the characteristic equation has real but distinct roots. In this case, you're going to look at the situation whereby the characteristic equation have repeated roots. So let's start. Now, you're saying that if the characteristic equation has a repeated root, say lambda, then for second order with lambda 1 and lambda 2 being the same, the general solution y of x is simply going to be c1 e raised to the power x, lambda x, plus c2, but because it's a repeated, listen, with the next one, we multiply the c2 by x, and then e raised to the power the same lambda x. So that is for a second order. So if we look for third and fourth order, so for the third order, we are going to have lambda 1 equals lambda 2 equals lambda 3. So the general solution is going to be c1 e raised to the power lambda x plus c2x e raised to the power lambda x plus c3 x squared e raised to the power lambda x. So what is seen is that there's an increasing power of the x. It starts from x equal to 0 here, x equals to 1, x raised to the power 0, x raised to the power 1. So here, x raised to the power 0, x raised to the power 1, x raised to the power 2. So for a fourth order, which is lambda 1 equal to lambda 2 equals to lambda 3 equal to lambda 4, the y of x becomes c1 e raised to the power lambda x plus c2x e raised to the power lambda x plus c3 x squared e raised to the power lambda x plus c4 x to the power 3 e raised to the power lambda x. So let's assume, so these are the roots. So let's start with an example. We want to find the general solution of the following differential equations. This one, the second order, third order, and then the fourth order, seventh order. So let's start with the second order. Here the characteristic equation is lambda squared minus 4 lambda plus 4 equal to 0. If you factorize, you're going to get lambda minus 2 squared equal to 0. So that means you have lambda 1 and 2 all being equal to 2. So the characteristic equation has a root of 2, which has a multiplicity of 2. So we are going to say y of x is going to be c1 e raised to the power 2x plus c2x e raised to the power 2x. So this one means that y1 of x is e raised to the power 2x. And the y2 of x is x times e raised to the power 2x. Let's look at the third order here. The characteristic equation is lambda cubed minus 9 lambda squared plus 27 lambda minus 27 equal to 0. And if you factorize, you're going to get lambda minus 3 cubed equal to 0. So that means you have lambda 1, 2, and 3 all equal to 3. So that means y1 of x is e raised to the power 3x. y2 of x is x e raised to the power 3x. And the y3 of x is x squared e raised to the power 3x. So therefore, y of x is c1 e raised to the power 3x plus c2x e raised to the power 3x plus c3 x squared e raised to the power 3x. Now we can get where this is coming from when we get to reduction order. Once we know one of the solutions, you can use the reduction order to reduce the equation to get the other solution. That's why you see this trend coming in. Let's look at this seventh order. The characteristics equation is lambda to the power 7 plus lambda to the power 6 minus 21 lambda to the power 5 minus 5 lambda to the power 4 plus 160 lambda to the power 3 minus 72 lambda squared minus 432 lambda plus 432 equal to 0. Now the characteristics equation, that if you factorize, you're going to get lambda plus 3 raised to the power 3 times lambda minus 2 raised to the power 4 equal to 0. So here I have two different roots by each of them repeating. So I have lambda 1, 2, you have lambda equals negative 3 and lambda equal to 2. And this one is having a multiplicity of 3. This one having a multiplicity of 4. So we can see y of x. In this case, we treat them individually. We pick the 3 and say we have c1 e raised to the power negative 3x plus c2x e raised to the power negative 3x plus c3 x squared e raised to the power negative 3x. So we have exhausted the negative 3 as a root, that we come to the 2. So it becomes c2 e raised to the power 2x. You see that here we start again because it's a different root. Sorry, c4, not c2, plus c5 x e raised to the power 2x plus c6 x squared e raised to the power 2x plus c7 x cubed e raised to the power 2x. So this is the general solution for this problem. Let's look at the second example. We want to solve this IVP. So here the characteristics equation is lambda squared minus 2 lambda plus 1 equal to 0. And if you solve it, you're going to get lambda minus 1 squared equal to 0. We have lambda 1 and 2 equal to 1. So the general solution is c1 e raised to the power x plus c2x e raised to the power x. Now we have been given an initial condition. The first one, y of 0 equals 3. So you put them inside this. You're going to get c1 e raised to the power 0 is 1. But here there's a 0 time, this is 0. So c2 is 1 equals to 3. So therefore, this implies that our c1 is 3. Now for the second condition, initial condition, is a derivative. So that means you need to differentiate this equation. So y prime of x, if you differentiate c1 e raised to the power x, you get c1 e raised to the power x. And here we must apply product rule. So we hold this and differentiate, we get 1. So that becomes plus c2 e raised to the power x. We now hold the x and differentiate, we get the same thing. So c2x e raised to the power x. So y prime of 0, well, now this will give you a c1, this will also give us 1, so c2, but this will go 0 and it goes to 4. But we know c1 to be 3, so c2 is equals to 4 minus 3, which is 1. So therefore, we can say that the solution is 3 e raised to the power x plus x e raised to the power x. Thank you for watching.